Okay, so looking at this here, so we're finishing up chapter 5.1. And the first thing we're going to look at is interior and exterior angles. Yep. Interior angles, well, they're going to be what? Inside. Interior angles are inside the polygon. Exterior angles are outside. Well, that's not too bad. They're kind of exactly what they say, yes? Interior is inside, exterior is outside. Now, the sum of the measures of the interior angle of a triangle are 180 degrees. So when we add all three angles inside the triangle together, we get 180 degrees. And we knew that, yes? Sum of the interior angles of a triangle is 180. They're always going to add together to be 180 degrees. So the sum of the three interior angles will always equal 180. So looking at this problem here, what do I know about the three angles here? They equal 180. And it's asking me to find the value of x and classify the triangle by its angles. So I know that these three angles, so 58 plus 47 plus angle x is equal to 180 degrees. So they add together to be 180. So we can combine like terms, yes? So 58 and 47 would add together to be what? 8 and 7 would be 5, carry the 1. And this would be 105. Do we all agree with that? 87 and 47? 58 and 47 would add together to be 105, yes? So now what do we need to do to solve for the value of x? We need to subtract 105 from both sides. And when we subtract 105 from both sides, we get that x is equal to 75 degrees. So the value of x is 75. Now, how would we classify this triangle based off its angles? What would we call it? It would be acute. It'd be an acute triangle. Now, yes, we would actually call this one scalene. I would consider this a scalene triangle, but we can't call it that yet. So at the end, or towards the end of chapter 5, I can't remember exactly where, we will get a property that will let us be able to say that this is scalene, but we can't say it at this point here. We can't say it at this point here, because we don't have anything to really relate the angles to their side lengths, or kind of know how are they connected. So we haven't really gone over that. We haven't talked about that yet. So we can't say anything about the side lengths because they didn't tell us anything. But we will get there. We will get to a point where we can connect the side lengths to their measures. Now, any questions on this here? Let's look at this one here. Now, we know these three angles add together to be what? 180, and we want to know the value of x. So we know that x plus 96 plus 21 is going to equal 180 degrees. The interior angles of a triangle add together to be 180. So we set it up. Now we can combine like terms, our 96 and 21. And what can we do? We can let's leave. Any questions on how we found the value of x? Now, how can I classify this triangle by its angles? How many angles does it need to have to be an obtuse triangle? How many obtuse angles? 1. Because if we have one angle greater than 90 degrees, it will be obtuse. If we have one angle equal to 90 degrees, it will be right. And if all the angles are less than 90, then it is acute. Questions on this here? We good with this here? Do we need to see another example one like this here? We feel comfortable with these here? Yes? Let's look at this one. This one here is a little bit different. A little bit different. Find the measure of each acute angle. So I need to find the measure of this angle and this angle, yes? But I can't find those, I can't find out what the exact value of those two angles is because I don't know the value of what? X. So we need to find the value of x. Now, what do I know about all three angles inside of a triangle? They equal 180 degrees. They add together to be 180. So what can I say? I can say 2x plus x minus 6 plus, what's the other angle? Equals 180. Because again, all three angles inside of a triangle add together to be 180 degrees. And it just works out for this problem here that one of the angles is 2x and the other is x minus 6. Now at this point here, we can drop the parentheses. We really don't need them. And we can combine like terms. So 2x plus x would give me 3x because I have how many of them? I have 3 of them. Now negative 6 plus 90 would be plus what? 84, because negative 6 plus 90 or 90 minus 6 would be 84. So we've combined all the like terms, yes? Now we need to get x by itself. So what's our first step in getting x by itself? We can subtract 84 from both sides, because that's going to be the easiest step to do first. And when I subtract 84 from both sides, I get 3x is equal to 96, because 180 minus 84 would give us 96. And our last step, divide by 3. Let's extend the page. So x is equal to, so the answer for this problem is 32 degrees, yes? No. Because what did it ask? It asked for what? The values of each acute angle, yes? So what we have to do is we have to take 32 and plug it back in. We have to do 2 times 32. 2 times 32 would be, so this angle up here is 64 degrees. The other one we have to do is 32 minus 6. 32 minus 6 would give us 26. So the other angle is 26 degrees. So our two angles are 64 degrees and 26 degrees. Any questions on this here? Any questions on this here? Anything we've done so far? We good with these here? Now, if you feel like, for some reason, I did this wrong, these numbers don't look right, especially when it's asking you to find the actual angles. What do we know about these angles? These all add to be 180. So you could type these into the calculator, 64 plus 26 plus 90, and if it equals 180, they're the right angles because they have to add together to be 180. If they don't, then they're not right, because a triangle in Euclidean geometry, the geometry that we have here, will always add together to be 180. These two here would be 90? Yeah. Yep, that's true. Questions on this here? Let's look at this one here. This one here looks a little bit harder than the last one, yes? This one here looks a little bit harder than the last one. What y'all think? Well, what do we know about these three angles? They add together to be 180. So 3x minus 17 plus x plus 40 plus 2x minus 5 is 180. It's still 180 degrees. They're still going to add together to be 180. Now, once we get this set up, we're going to combine like terms. Well, 3x plus x is 4x, plus 2x gives me 6x. Negative 17 plus 40 minus 5. Now, at this point here, it might be challenging to add these three together in your head or do these all at once. So you can type in a calculator if you wanted. You can do negative 17 plus 40 minus 5 and hit enter, and it'll give you your answer. Well, negative 17 plus 40 would be 23. Minus 5 should give us, put that down. Should be plus 18. Because negative 5 and negative 17 would combine to give us negative 23. And 40 minus 23 should be, or 22, should be 18. Do y'all agree with this here? For those of you who do have a calculator. Negative 17 plus 40 minus 5. 18. Any questions on this here? Any questions on anything we've done so far? So what do we need to do next? We need to get x by itself. So we'd subtract 18 from both sides. And when we subtract 18 from both sides, we get 6x. Divide both sides by 6. Any questions on this here? So did this one here ask for each acute angle? Well, no. What did it ask for? The value of x. If we wanted to, it wouldn't be too hard to find each one because we could do 27 plus 40, which would give us 67. We could do 2 times 27 minus 5. Well, 2 times 27 would be 54. Minus 5 would be 49. And then we could do the last one here. Because 3 times 27 would be 1, carry the 2. 81 minus 17 would be 64, should be 64. And those would be our 3 angles. Questions on this here? Questions on anything we've done so far? Yes? If the 2 is on the outside of it had 2 times x minus 5, where the x minus 5 was in parentheses, then yes. Then we would subtract 5 and multiply by 2. Yeah. Any other questions on this here? Yeah, here we just needed x. So this here, the corollary theorem, corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. They add together to be 90. So this here is going to work every single time. That if we have a right triangle, the other 2 angles of it will add together to be 90 every single time. And really, we could call this x, helps if I have a pen, x and y. Can I show you this here? Because these three angles will always add together to be 180, yes? And this is always, we're going to have a right angle. If it's a right triangle, we'll always have a right angle. So I could subtract 90 from both sides, which would just tell me that x plus y is equal to 90. Now, is it wrong to add all three together and set them equal to 180? No, because it will still work. It will still give us the answer. This here is just a shorter way to do it. Kind of like this one here. We're given this triangle, and we're told that it's a right triangle, or we're shown that it's a right triangle, because we have one right angle. So I could do it the way that we did the first ones, or the first few, and set all three angles equal to 180, and I'd get the answer. But with our new theorem, we can say that these two angles here equals 90, because the acute angles of a right triangle will add together to be 90 degrees every single time. So now we can combine like terms. Well, 2x plus x would give me 3x. Negative 2 plus 5 would be plus what? Now what would we do next? We would minus 3 from both sides. These would cancel, leaving me with 3x equals 87. Divide both sides by 3. And x equals 29. X is equal to 29 degrees. And that's, again, that's all this asks for. But we could plug it back in and do 29 plus 5, which would give us 34 degrees for this angle. Or 2 times 29 minus 2, 6, 4, 56. Questions on this here? Any questions on any of this here so far? How do we feel about triangle so far? We kind of like triangle so far? Yes? Now this here is the other kind of main proof, or kind of one of the other postulates we're going to look at, theorems. The exterior angle theorem of a triangle is equal to the sum of the non-adjacent interior angles. The exterior angle is equal to the sum of the opposite two interior angles. Okay? Now, what I'm about to show you don't have to write down, but I'm going to show you kind of how this works. I'm going to call this angles 2, 3, and 4. Well, we know that angle 4 plus angle 3 plus angle 2 is equal to 180 degrees, yes? Would y'all agree with this here? What's the first thing we did? We say the sum of the interior angles of a triangle is 180, yes? What do I know about angle 2 plus angle 1? Those equal 180 degrees because they make a straight line, yes? Do both of these equal 180? Since both of these equal 180, what I can say is that angle 4 plus angle 3 plus angle 2 is equal to angle 2 plus angle 1. So are we good with saying this here? Because they both equal 180, so they're equal to each other, because they equal the same thing. Do you have an angle in common with both of these? Yes. Four and 3 were the opposite two interior angles, weren't they? So here I can show that those two angles added together will equal the exterior angle. will equal the measure of the exterior angle. And that's it. So that's really just kind of showing this proof works, or kind of the proof of this. And it's really helpful. It's really helpful for problems like this here. Because if I wanted to find that exterior angle, I would have to solve for this angle right here, another interior angle. And once I found it, then I would subtract it from 180 because those two form a straight line and they would add together to be 180. Yes? But because of the exterior angle theorem, I know that the opposite two interior angles will add together to be the exterior angle. So x is equal to what? 21 plus. And what is 21 plus 34? That's it. That is it. That's all we have to do for this here.
Also, like,
Yes.
corresponding
Yes, well, we deal with corresponding angles if they are parallel, if we have parallel lines, then we would talk about corresponding angles. Now, it could be, well, not really, because we could talk about corresponding angles, but none of these angles would really be parallel because they would have to cross at some point with most polygons for triangles. Now, we will reach a part of the chapter where we talk about polygons, four-sided figures, because once we hit four-sided and higher, we can have parallel lines. And that can help, or kind of help us see what some of the angles are. But we haven't gotten there yet. So let's look at this next one here. So again, that alternate, or that exterior angle theorem. So we have the exterior angle is 122 degrees. So we know that this here is equal to the sum of the opposite two interior angles. So it's going to be equal to the sum of x plus what? 90. Any questions on how we got this set up? Any questions on how we set this up? Now, what would I need to do to get the value of x by itself? So I need to subtract 90 from both sides. And when we subtract 90 from both sides, we will get x by itself. And we get the value of x is 32 degrees. Any questions on this here? Any questions on anything we've done so far? Now, that's not the way that we have to solve this one. We could solve it differently. I do know that these two angles make a straight line, yes? So they add together to be 180. So this angle here, we have 8, 3, 5. Because 180 minus 122 would be 58. Now these three angles here add together to be 180. But we also know that it's a right triangle, yes? So these two angles here have to add together to be 90, yes? So I could say x plus 58 equals 90. And subtract 58 from both sides, and we get x is 32. That's the same thing we got, yes? Is it a little bit easier to use the exterior angle theorem on this? Yeah, it still works. It works the same. We get the same answer. It's just a little bit easier. Any questions on any of this here? So again, we have an exterior angle and the opposite two interior angles. So I know 100 degrees is equal to what? 51 plus 2x plus 3, or 2x plus 3 plus 51. The order doesn't matter. As addition, we can add anything in any order. Well, the like terms are 51 and 3. Well, 51 plus 3 would be what? 54. What do we need to do to get the value of x by itself? Subtract 54 from both sides. And if we do that, these cancel. 2x. 100 minus 54 would be. And at this point here, we would divide both sides by 2. That'd get x. 46 divided by 2 would be. So the value of x for this problem here would be 23. And again, if we wanted to find the acute angles or the missing angles lengths, we can plug it back in. And we could do 2 times 23 plus 3. Well, 2 times 23 is 46, plus 3 would give us 49 degrees. Any questions on this here? Any questions on anything we've done so far? Let's do this one here, because I was thinking about skipping it, but I think we should do this one here, because this time, do we have any numbers for just an angle? No. I mean, we do have numbers if we want to get technical, but we don't have a single value for any one of these x's or any one of these angles. They all have a variable in them, yes? But what do we know? We know the exterior angle, which is equal to the sum of the opposite two interior angles. So it'd be 2x plus 103 minus x. Yes? The exterior angle is equal to the sum of the opposite two interior angles, or equal to the sum of the non-adjacent, or the exterior angle is equal to the sum of the non-adjacent angles. And we get this here. Any questions on how we set this up? Any questions on this here? We can combine like terms. Well, there's no terms on the left-hand side, so we'll just have 6x minus 7. But 2x minus x would be just 1x. Now, there's some different things we could do next, but what would we do next? What would be our next step? We can add 7 to both sides. Because negative 7 plus 7 will cancel, and I get 6x is equal to x plus 110. Then we'll minus x from both sides, because again, we need to get the variables on one side, and then we need to get the values of x on the other. So 6x minus x would give us, and it's equal to, and last but not least, we divide both sides by, divide both sides by 5. X is equal to 22 degrees. Now we could go back through, because it just asked for the value of x, but again, we could go back through and plug them in for each of those different spots to find the value. Any questions on any of this here? We need to see another example of one of these here. Okay? This one here? Find the measure of angle 1. So let's do this here. I think this is the last one on the note sheet, yes? So what do I know? I know that the exterior angle is equal to the sum of the opposite two interior angles, yes? I know that the sum of the interior angles add together to be what? 180. I know that angle 1 and this exterior angle add together to be 180. So if I can find out what this angle is or this angle is, can I find out what angle 1 is? Yeah, so first we just need to find the value of x. Do what? Well, it would get the sum of these two. It wouldn't really give us what angle 1 is. So there's two ways we can go about it. One of them is going to be saying that 5x minus 10 is equal to 3x plus 40, because the exterior angle is equal to the sum of the opposite two interior angles, yes? Do we have any like terms on either side here? Yeah, so we can just start solving. So we can add 10 to both sides to get the value of x by itself, because these would cancel. And that would give me that 5x is equal to 3x plus 50. Then what would we need to do? We would subtract 3x from both sides. 3x and 3x would cancel, leaving me with 2x is equal to, last but not least, we would divide by 2. Any questions on how we found the value of x? So this angle here would be 3 times 25, which would be 75. So we would have 40 plus 75 plus, we'll call it x, is equal to, well, 40 plus 75 would be 115. And we would subtract 115 from both sides. And x would be, so the measure of angle 1 would be 65 degrees. Any questions on this here? Any questions on this problem here? We good with this problem here? Yes? And to be 100% honest with you, I would not solve it this way. Actually, yeah, we have to. I thought I wouldn't, but I can't. Because is angle 1 and x the same value? No, I'm glad I showed you this, because this here would be the way I'd really want to solve it. I would want to solve these three here set equal to 180. But again, it's very easy if we're not looking to set those equal, because they're not the same value. Because we found out that angle 1 was not 25 degrees, was it? No. So as much as we want to do it, I would love to do it that way, we're not able to. We have to go the other way, unfortunately. I'd love to do the other way. It would make it a lot easier, but I can't, unfortunately. Any questions on this here? Well, we're not doing it out of the book anymore, so